Why is hydrofluoric a weak acid? And what was number 2? Why is hydrofluoric a weak acid and hydroiodic, hydrobromic, and hydrochloric acid are strong? Aren't they all members of the same family? They are. But this is the odd member out. So why is that? Well, we'll have to figure out why that is later. But that's what's observed. HF is weak. Even though HF is a weak acid, chemical properties, when we think about chemical properties, we got to think in a broader context. How many different patterns to chemical reactivity do we see in nature? How many main types of patterns? How many types of chemical reactions do we see in nature? Hundreds? Thousands? 3? 3? Yeah, 3 is correct. We see 3 main types of reactions. Well, HF is a weak acid, so as far as acid properties go, it's not really of any concern. If you spill some on you, it doesn't really burn. For example, if you spill hydrochloric acid or hydroiodic acid, it would burn. The problem with HF is its metathesis properties. And so when HF, if you spill HF on you, it's okay, but eventually it'll permeate through your flesh, and then when it contacts bones, that's where trouble starts. When it contacts bones, then the fluoride ion likes to substitute for the hydroxide ion in bones and precipitate out calcium fluoride. And the precipitation of calcium fluoride, I heard, is very, very painful and can lead to death, eventually. And so HF has really nasty metathesis properties because fluoride likes to precipitate. Now, like chloride, would chloride precipitate out with calcium? No, chloride and calcium soluble. Bromide? No. Iodide? No. But fluoride? Yes. Because fluoride was one of those ones, that was kind of, we didn't put it in the same family. But it's not because of the acid, it's because of the solubility or the ion combination. So fluoride, this is why they put it in toothpaste, but in toothpaste, if you have small quantities, it's okay. If you have large quantities of fluoride, then cause trouble, of course. But anyway, HF is important here because there's a movement right now trying to ban HF from the Torrance refinery. Have you heard about that? They use HF in the refinery over here, and so a lot of people are concerned. HF is a weak acid, but it's a very dangerous chemical because it's metathesis properties. That's hydrofluoric acid. Below that is, I don't know if you recognize this one. You probably don't. This one we'll talk about later. This is methanoic acid or formic acid. So don't worry about that one. Meth, meth means what? How many carbons? Meth, F, prop, but, 1. So this is methanoic acid. Do you see this? This is called ethanoic acid. Ethanoic acid has 2 carbons. But you see, this is the acid part. Do you recognize this acid? It's C2H3O2. So it's HC2H3O2. HC2H3O2 is acetic acid. This is acetic acid. Vinegar is 5% acetic acid in water, 95% water. And so this is methanoic acid, this is ethanoic acid. Methanoic acid is called formic acid. Ethanoic acid is called acetic acid. Let's continue on here. What is this acid? H2CO3. H2CO3 is carbonic, carbonous, or hydrocarbonic acid. Basically, those are our only three choices. Carbonic, carbonous, or hydrocarbonic acid. What is it? Well, it depends on the anion. What is the anion? Anion is carbonate. Carbonate means it's got to be carbonic acid. So this is H2CO3 is carbonic acid. Carbonic acid is in these quotation marks because carbonic acid is inherently unstable. It decomposes. Carbonic acid ends up decomposing into this one. Name this one CO2. Carbon dioxide and water. So carbonic acid is inherently unstable, decomposing into carbon dioxide and water. Most people name this according to the ionic name. The ionic name is hydrogen sulfide. But if you were to name this as an acid, it would be called close. But it's not, we have choices. Our choices are sulfuric acid, sulfurous acid, or hydrosulfuric acid, depending on the anion. What is the anion? Well, H plus is the cation, the anion is sulfide. So sulfide, it's an IDE ending, like chloride. Chloride and sulfide both share the IDE ending. When chloride makes an acid, it makes hydrochloric acid. When sulfide makes an acid, it makes hydrosulfuric acid. So the correct name is hydrosulfuric acid or hydrogen sulfide. What's below that? This would be an ion. This is called the we've got the whole series here. This H3PO4 is called phosphoric acid. H2PO4 minus is called dihydrogen phosphate. HPO4 2 minus is called monohydrogen phosphate. And then finally PO4 3 minus is called phosphate. So this would be dihydrogen phosphate. This one, NH4 plus, is called ammonium, which is a weak acid. HCN. HCN ionic name is hydrogen cyanide. Acid name is what's the anion? Anion is cyanide with a D. Same thing as chloride or bromide or iodide or fluoride. And so if you have an IDE like chloride and it makes an acid, we call it hydrochloric acid. If we have cyanide, which is IDE, and it makes an acid, we call it hydrocyanic acid. So this is called hydrocyanic acid. Then we have, what's this one here? HCO3 minus? HCO3 minus is called, there are two names. You should know the new name and the old name. What's the new name for that? Well, the new name is, it's just, this is what we call an acid anion. It's just the anion plus an H plus. So the anion here is carbonate, right? Or is that carbonite? That's carbonate. We added hydrogen, so we call it hydrogen carbonate. Two words, hydrogen carbonate. The old name for this is, starts with a B, bicarbonate. In fact, the old name is probably more common than the new name. This is bicarbonate ion, and it's an acid. It's kind of a weak acid. a little stronger than HPO4 2-, which is also a very weak acid, but it's better than water. Water is not a very good acid. But there are worse acids than water. What are worse acids than water? This one which we call the hydrogen sulfide ion, this one which we call ammonia. Ammonia, typically we don't think of as an acid. Ammonia we usually think of as a base. And then hydroxide, which we usually think of as a strong base. And then finally, hydrogen and methane. Methane is not a very good acid. In fact, methane is the worst acid on this chart. The strongest acid is HClO4. These acids that are worse than water are very significant here. But because of the conjugate relationship, if methane loses a proton, then it forms this one. This one is the most powerful base on the chart. This one loves H+. If you can find an H+, it'll take it. And so CH3-, do you know what that's called? CH3- is called the methide ion. Methide. What's HS- called? Hydride. O2-? Oxide. NH2-? Amide. Methide, hydride, oxide, amide. S2-? Sulfide. These ones are the powerful bases. And hydroxide, of course. All of these are powerful bases, but you don't have to memorize these. These are on the chart. The 7 strong acids you didn't memorize. These are less powerful, but it's still significant. Phosphate is a pretty good base. And we have carbonate, we have cyanide, we have ammonia, monohydrogen phosphate. And so there's a seesaw relationship here. The conjugate relationship says if the acid is very weak, the base is going to be very strong. And these two are related. I guess we're out of time, so I'll stop this here.